Yes. Am I visible in the screen?
Your chest.
Okay. Am I now? Am I?
It's too zoomed in.
Yeah. Yeah, now we should be fine, right? Thank you. Am I visible now? Yes. Someone have to keep an eye. You need to shift the camera? Somebody have to keep an eye, and when it shuts after 20 minutes, you have to just come and press this red button again so that it starts to record, right? Okay. So tell me one thing, what do you think is econometrics all about? How many of you have done econometrics in college? One. Please put your hands up. 1, 2, 3, 4, 5, 6. Quite a lot. Right. So what do you think is econometrics all about? Yeah, let's start some brainstorming. What did you learn in college in econometrics? For all those who have done econometrics, what did you learn in college?
It's a way of measuring data that we have collected maybe to a survey or to this. Once you get the data, how to make sense of it. Econometrics uses tools to do that.
So what he says is, once you have data, how to make sense of the data. Okay, econometrics is a set of tools which helps you to do this. Any other definition? That's a very good definition. But any other definition of econometrics? Yes.
To check or prove the economic theories which have already proven or which we are going to prove.
So it's a tool of proving or checking whether they apply or not certain economic theories which either have been proved previously and need to be reproved or need to be put to a test for the first time. So it's a way of testing economic theories is what you want to say. Yes, that's another good definition. Is there a third definition? So one is econometrics is a way of making sense of the data, the other is a way of proving theories, so testing theories. Any other definition? For those who have not studied any econometrics, what do you think this subject is? What do you think this would be? Yeah? Anything that comes to your mind. Yeah?
Can we do scientifically or numerically sort of explain an economic theory or an idea?
Absolutely. So econometrics is a way of scientifically or quantitatively explaining a phenomenon or testing a theory. And all these definitions are fair, and I'm surprised that even when you did not really study econometrics, your definition on the top, right, which is a very good thing, and you should be proud of it. Right? Now, econometrics really is a combination of mathematics and statistics. And by statistics, I mean not really the descriptive statistics that you do in college, but more inferential statistics in order to test economic theories, estimate economic relationships, measure various economic quantities, and so on. Yeah? Now today we'll talk about some of the most fundamental ideas in econometrics. They are the most important ideas that I always start with, and which I think is a very fruitful thing to do, is the idea of a random variable. Now what's a random variable? All those who have done econometrics, can you tell me the definition of a random variable? You have random variables in your syllabus, don't you? It's not a very? Which do not have any particular value.
It is free to take any value.
It's free to take any value. Okay, we are getting close. Any other definition of a random variable? Yes?
Free to take any value with equal probability.
With equal probabilities, I don't know. Okay, not necessarily. Anybody else?
It quantifies the outcome of
It quantifies the outcome of a?
events or some
What?
situations.
I think she is getting the closest. A random variable is a real valued representation of the outcome of a chance experiment. Don't write down, think. There is not a press conference. We are talking to you. So, a random variable is a real valued representation of the outcome of a chance experiment. Now, what do you mean by real valued outcome? When I say something takes a real value, it is represented by a real number. Yeah, what's a real number? A number which can be represented by decimal points is a real number. Yeah? Okay. So let's take an example. Let's take an example. What do you mean by that? Suppose we are tossing a coin. Okay, so tossing a coin is a chance experiment. Why is it a chance experiment? Because the outcome can be either a head or a tail. Once I toss a coin, before the coin lands, I have no way of saying whether it will be a head or a tail with certainty. I can say that there is a 50% chance of it being a head or a tail. And if I know that the coin is really not a balanced coin and a biased coin, then I might say that there is a 3/4 chance that it lands a head, 1/4 chance that it lands a tail, and so, right? But I can never predict exactly whether it will land a tail or a head, right? Therefore, when I toss a coin, I'm having, what I'm really having is a chance experiment, and we're looking at the outcome of a chance experiment. Can you give me more examples of chance experiments? Can you give me some examples of chance experiments? Rolling a die is an outcome of a chance. Is it a chance experiment? And what will be the outcomes of the chance experiment? The number on the uppermost face of the die could be 1. You could think of outcomes alternatively. For example, the outcome could be an odd number or an even number. The outcome could be a number less than 5 or more than 5. The outcome could be a number less than 1 or greater than 5. Depends on how you pose the question. Right? But the point is, once you roll a die, the outcome, however you have defined, is a result of chance. Everybody's got this? Any more definitions of a random variable or not a random variable or of a chance experiment? Any more examples of a chance experiment? Yeah? Picking a car. Okay. Do you think, how many of you come from Kurla station by bus? Most of you? Okay. Now suppose you take a bus, climb into a bus at Kurla station and you come to Kali. It takes you a certain amount of time. Can you exactly predict how much time it will take? No. So the outcome, the time taken by you to travel from Kurla to the university campus is in a sense the outcome of a chance experiment. Right? Suppose I pick up one of you and ask that person their age, and anybody can be picked up. Then can I predict exactly to the day what is the age? I can't. Right? So if I pick one person from you at random and ask them what their age is, the outcome would be, my experiment would be a chance experiment because the outcome is uncertain. It will have a probability distribution for sure, but I can't predict what specific outcome will have. Right? All such experiments are called chance experiments. Now the outcomes of all chance experiments are not necessarily real numbers. For example, the outcome of the age experiment is a real number. Right? The outcome of the bus experiment is a real number. But the outcome of a toss is not a real number. It's a head or a tail, right? So different kinds of chance experiments have different types of outcomes. Yeah, right? For example, I loved the movie the Jungle Book. Did you like it all? Yeah. Okay, but I'm not sure if I pick one of you and ask you whether you like the movie. I'm not sure you say I liked it or I didn't like it, right? So the response of a person, of a randomly picked up person, to whether he liked or he or she liked the movie Jungle Book is a random variable. It's an outcome of a chance experiment. It's not necessarily a real value, right? So what's the difference between a random variable and the outcome of a chance experiment? The random variable is a real number which represents the outcome of a chance experiment. How does it work? For example, when we toss a coin, I say the outcome could be head or tail. And I might say, right, so what are the outcomes? This could be the outcome or this could be the outcome, right? Now, these are not real numbers. They're symbols, H and T. But suppose I say that you will get 1 rupee if it lands up heads, and you will lose 1 rupee if it lands up tails, then your earnings become +1 here and -1 here, right? So if the outcome is H, it gets represented by a number +1. If the outcome is tail, it gets represented by a number -1. Right? Okay. So what have I done here? I have defined a rule which assigns to every outcome of a chance experiment a unique real valued number. In a sense, what I have defined is a function. Does everybody know the meaning of a function? When I say y is a function of x, what does it mean? 100 times. What does it mean?
I depends on
Y depends on X. It's a?
It's a relationship with y.
Yeah, but what kind of relationship?
Depending relationship.
Direct relationship.
My dog depends upon me. If I don't feed him, nobody feeds him. Will you say that my dog is a function of me? So what do you mean by depend?
Value that y takes will be dependent on the value that x takes.
Every value on x will have a value on
Yes, so this gentleman is right. What he says is, if you define a function from x to y, you think of a set x, you think of a set y, you think of some elements of the set x, yeah? You think of some elements of the set y, they could be say y1, y2, y3, y4 for example, yeah? And you think of a rule which tells you how to assign each value of x to a unique value of y. So this rule must cover every value of x. And this rule must tell you how to assign each value of x to a unique value of y. Yeah, in which case we say we have a function from x to y. This rule which tells you how to associate these is the function. For example, now all of you would have got your roll numbers. There is a rule which we apply to giving you roll numbers. It's an alphabetical order, right? Okay. So the rule tells me that if I take this gentleman, depending on what his name is, I'll assign a number to it. So each of you will be assigned a unique number. Nobody will have two roll numbers. So we will be defining a function from the set of students to the set of real numbers, and that function will be called roll numbers. Right? That function, that assignment rule will be a function. Yeah? Like for example, if I say the number of siblings that each one of you have. Okay? So if I put all your names here, and then the number of your siblings here, right? Then each of you, and if I allow 0 as well there in the numbers, then each of you will have either 0 siblings, 1 siblings, 2 siblings, 3 siblings, etc. So, if I ask you, so what are they to be doing? That rule which assigns to each student the number of siblings that the student has. Each student will have a unique number of siblings. Will define a function. That rule will define a function. If I define a function, if I take each of you as a set, name of all of you, as a set X, and Y contains the list of all dates, and if I assign each of you, okay, to an appropriate number depending upon your birth date, I say each student associated with his or her birth date, I will be defining a function from the set of students to the set of real numbers. Right? Now each of you will have a unique birth date. Some of you might have the same birth date, which is fine. Each X has to be assigned to a unique Y. You can't work backwards in many cases because some of you might share a birth date. So for the same birth date, you might not have a unique student here. But as long as each X can be assigned to a unique Y, you have a function from X to Y. Is this clear? Right? So suppose if you go to a kindergarten and look at all the children. So it's say for example it's the parents meeting in a school, and you have all the children in your class, and suppose you're a school teacher of junior KG, and you have all these kids here, and you have all the parents there. And suppose you are told to take each child to the parent. Each child will have a unique parent there. Suppose only one parent is allowed, right? Okay, each child will have a unique parent there. So each child can be assigned to one parent. Some children might have the same parent. You have a function. But if two parents are allowed, unless you define a pair of parents uniquely with each child, you will not have a function, because each child might be associated with a mother and a father. Right? So you will not have a function. You have a function only if there is a unique person or a unique pair or a unique something that you can associate each of the student to. Right? That is what one means by a function. Okay? So in that sense, really you are defining the function from children to parents. Can you define a function from parents to children? Can you assign each parent to a unique child? No, so you don't really have a function from parents to children. So you see how the problem of how that dependence upon becomes, in ordinary language you say children depend upon parents. Right? So children should be Y and parents should be X, but mathematically you can't define that function. But you can define the function from children to their mothers or their fathers or parents thought of as a pair. Right? Okay? So that's all a function is. It's a rule. It's a rule which tells you how to associate each element of the set X with the unique element of the set Y. Clear? Give me some examples of functions. And not your textbook statistics ideas, but something to do with your day-to-day lives.
Body parts and body are used.
Body parts and
Body, like eyes are associated with seeing and like.
so body parts and their function. Yeah. A student and his marks. Each student will be associated with a unique set of marks. So many students can have the same marks. You can therefore define a function from students to marks, but can you define a function from marks to students? No. Because each set of marks will not be associated to a unique student. No? It's a different thing. Right? Same thing about body parts and their functions. But is there a function? For example, can you necessarily assign each body part to a unique function? Depends on how you define function. For example, you see that the function of an eye is to see, then eyes uniquely with seeing. But if you think that eyes do actually many functions, then you can't have a function from eyes to the set of functions. Right? From body parts to the functions that they do. Yeah? So it all depends on how you so basically there is no hard and fast rule which says you can define the function from X to Y, you cannot. It all depends on how you define. It all depends upon how you define. Any more questions? Any more examples? Yeah? Any more examples? Yes, and then vehicles and then number plates. Exactly. So that's a function that you can define a function from a vehicle, from vehicles to numbers, and also from numbers to vehicles. Because each vehicle has a unique number, every vehicle has a number, and each number will correspond to a unique number plate, the unique vehicle. So you can have a function from vehicles to the numbers and from numbers to the vehicles. Are vehicle numbers necessarily real numbers? Are vehicle numbers necessarily real numbers? They're not. They could be MH04, whatever, right? So the MH part surely is not a real number. Yeah, any more examples? Yes?
Classrooms and the subjects that are being taught in.
Classrooms and will this look? So, but is this classroom reserved for economics? No. In a few hours' time, we'll have a lecture on physics here.
But so every subject will have a classroom.
But every subject should have a unique classroom. Every subject must have a unique classroom. Yeah, then it becomes a function. So the rule which tells you some computer how to assign a classroom to a subject. It will be a function.
So,
Yeah.
so accident and the people living there. The different people living in the flat may be Y and X will be the number of people living there. So we can assign X to Y.
So you can have, no. What you can have is each flat, and you can have the number of people staying in that flat. So you can assign each flat uniquely to a number of people staying there. You can assign each flat to the number of people staying there. So you can say flat number 1, how many people stay there? Nobody stays there, 0. Flat number 4, how many people stay there? 7 people stay there. So 4 to 7. Flat number 6, associated with number 9 because 9 people stay there. Flat number 10, just one person stays there, so 10 to 1. Right? But can you think of a number other way around? No, because one person, both flat number 11 and flat number 3 can just have 3 people staying there. So 3 will be associated with 2 flats. So the reverse function will not be there. Come again, I am not hearing you. Yes. So each owner, but each owner can have, one owner can have many flat numbers. No? If that person is a very wealthy person, he can own 3-4 flats. So an owner can be associated with 3 flats. He will not have a function. But each flat will have a unique, I don't know each flat, flats might not have unique owners. There can be people who hold flats in partnership with others. So you can't really define functions both ways. You can't be sure that every flat will have a unique owner. So you can't, yeah. Pardon?
Fingerprints.
Oh, yes. Fingerprints is a very unique thing. Each person corresponds to a unique fingerprint. Each fingerprint corresponds to a unique person. IQ. So each individual will have an IQ, right? So you can define a function from individuals to their IQs. But can you define a function from IQs to individuals? No. Right? Because given an IQ of 130, you can't find a unique person having that IQ. You can have many people, right? People and their blood groups. So what would be X? People or blood groups? X cannot be blood groups because each person will have a unique blood group. And therefore X will have to be people and Y will have to be blood groups. But each one blood group can be shared by lots of people. So you can't have a function from blood groups to people.
Lectures and their duration.
Lectures and their duration. Yes. Each lecture has to have a finite, unique duration. But of course the duration might have. So you can't have, so what will be X here?
Duration.
No, X will have to be lecture. Each lecture will associate a unique duration. You can't have it the other way around because a unique duration can be had by many lectures. No? A specific duration can be shared by many lectures. So X can only be something which can be associated with a unique value of Y. And every X has to be associated with a unique value of Y. Yeah?
Students and persons.
Yeah, but I give an example.
Seats with number of parliament
Seats and?
number of parliament
Yeah, so you're looking at the MPs and the parliamentary constituencies?
Seats are reserved for particular house. Sonia Gandhi city for particular seat.
So order in which people, so each seat will have a unique empty sitting there, and every MP will have a unique seat. So X can be MPs or X can be seats. Y can be MPs or Y can be seats.
Students and parents.
Voters and contestants. Voters and contestants.
Come again?
Voters and number of contestants.
Voters.
Yes, for the reality.
Come again, no?
People who vote will be X and the number of contestants.
The number of contestants will not be because, okay, so what you're saying is constituencies and the number of contestants.
So the number of nominees, let's say there are 3, the number of people.
Okay.
People who vote,
So suppose in the Karina constituency, 5 individuals are contesting the election. So all people, so what you're saying, if I get it right, each person in the Karina constituency is uniquely associated with number 5. That's what you're saying? Right. But can you have a function from 5 to the people in the Karina constituency? No, because this 5 number will be associated with every voter in the Karina constituency. So X will have to be voters in the Karina constituency. In each different constituency, each individual voter, and Y will have to be the number of individuals who are contesting elections in that constituency. Yes, so I think you've got a fair idea now of what a function is. Right, so basically then we can understand what a random variable is. You see the outcome of a chance experiment would be say H or T. My rule which says that you get 1 rupee if it's heads, and you lose 1 rupee if your tails, actually gives you a rule.